Okay, so I'm going to talk about vulnerabilities of the Internet of Things. Or I'm not specialized in threat management or threat intelligence, but we have a number of issues at our companies, and my goal this morning is to share these questions with you and possibly get answers. I'm not sure I will, but anyway, we can discuss that. So I'm working at a company which is called NFC Interactive. We are working, for instance, for the French railway company, where we are developing a maintenance system along the tracks. And of course, it means that we connect objects to some background and to some back office software. At the same time, I have a position at the University of Bordeaux. I'm a professor in computer science, specialized in network peer-to-peer communication, and I have a large amount of activity on drones. So, many industrial applications now, as you know, are using the Internet of Things. So the things are available in the physical world, but they begin to be available also in your body. For instance, this is a compass system that has been designed by the Seaborg Nest company, and it can be implanted in your body, and it gives you some sort of sixth sense, which means that when you are directed toward north, there is a vibration, and you know you are in that direction. So it brings a new sense to you, but it also means that it's new gates for hacking, for instance. So let's have a quick look at the figures of the IoT. Of course, we all know that the number of connected objects is increasing, but the question is what are the domains in which it is increasing? Of course, in companies, in government infrastructures, and of course in the home of everyone. And if you look at more precisely at what happens at home, these are the kind of objects that are being deployed in the real world. Of course, the figures are already false because it was done in 2013, and what was scheduled, we are already far beyond the target which is given here. Still, the thing which is important is that what is referred to as the Internet of Things, which is basically the many objects that you have at home, is increasing by a large amount, which means that it can raise many issues. The thing which interests me and where we have questions is not the risk related to the back office, for instance, or the way this object can be hacked going through the standard network, but the thing is that they are connected to the real world. You not only have sensors, like, say, temperature or whatever, but you also have actuators, which means that you can do something on the world. And so these kind of objects can be fed with input from the outside, but they can also act on the outside world. There is a strong belief, which is that when you have no physical connection, which means no network, basically you have some security. Of course, this is what is thought by most people, but we all know here that it is not the case. For instance, when you look at the US-Canadian border at Niagara Falls, you can believe that the US side is secured from the Canadian side, but the guys in marketing, they quickly understood that it's not. Okay, you can some sort of leak information from one side that can be seen on the other side. So, for instance, the casinos can make some advertisement that can be seen from the Canadian border to attract people on the US border. So there are other sources of input that needs to be considered. It reminds me of some work we've been doing a few years ago at the university on side channels attack, where basically what you do is you observe some information that leaks from a board. For instance, this can be timing, power consumption, temperature, and so on. And based on this information that leaks, you try to build a model of the board that you are using. For instance, in this case, you can trace RSI, part of the RSI code behavior just by observing the power consumption of the board. Of course, there are countermeasures that have been designed and implemented by the board's manufacturers, but we know that there are additional issues that arise thereafter. But it basically looks the same. There is information that leaks and that you can observe. The thing which is, I think, an issue with the Internet of Things is that it goes the other way around, which means that information from the outside world can be fed inside your object, and you did not expect that. So you have to deal with that. One of the reasons why I chose this topic for this presentation is the recent DNA sequencer attack that has been described widely on the web. Well, basically, there is nothing new. It's just an attack where you have some sort of input that, as we show that later, but just like some sort of buffer overflow, quite standard attack. Still, it began making me think about what can happen with the Internet of Things and with all kinds of objects. The basic idea of this attack was to code a virus inside as a DNA sequence, to synthesize the DNA that corresponds to this sequence, to put that in a sequencing machine so that it is compromised and that the virus can be run on the sequencer machine. So this is what they did. Of course, it was quite easy for them because they had all the software of the sequencing machine plus additional information. So it is most likely it will not work or it will not work long in the real world because countermeasures can be adapted. Still, it's a way to enter a system. Another way to enter a system, all of you have seen that recently, it's the Google Home that has been the target of many attacks. Well, basically, we could say Google hacks Google during the Super Bowl. It was not really hacking, but once again, it was something that had not been studied before it happened. During the Super Bowl, there was a commercial about the Google Home, and the guy in the commercial said, "Okay, Google," and many of the Google Home around the US began doing something. There are so this is some of the tweets that resulted from the thing. They also suffered many other attacks. There is one which I especially like, which is what I call the Burger King attack. There was an advertisement, a commercial by Burger King. They said plenty of good things, nice things about Burger King, and at the end they said, if you want additional information, just say, "Okay, Google Burger King." And of course, you know what happens. There is another attack which is more, this one is not really an attack, it's something funny, but we cannot consider it an attack. Something which is an attack is this dolphin attack that has been done by the Chinese. We were talking about them just before. The basic idea of the dolphin attack is that you record "Okay Google" on some simple device, you change the frequency of the voice, of the sound, and you replay that. And if you target frequencies that cannot be heard by a human, but that can still be understood by the device, it works. And so this is what they did, and they targeted Alexa, Cortana, Siri, and many others. And there is a nice table that summarizes what happens, and you see that it's been working on many devices. So it's a way to hack Internet of Things or many different objects or mobile phones or assistants just by using the input that they are supposed to deal with. Still without using any network connection or whatever. There are many other things that you can hack using the input of the system. You can hack a chicken, for instance. You can easily hypnotize a chicken, and you have the process here if you want to try. If you have a chicken at home, you can try with him. You can also hack someone's brain. There is a nice study that shows that basically everyone is epileptic. So by blinking a light, you just have to find the proper frequency for each person, and you can create, I don't know the word in English, an epilepsy crisis. I don't know if it's
a seizure.
A seizure. You can create a seizure just by selecting the proper frequency. And you know that there are many bulbs that can now be connected, that can now be switched on and off using either Bluetooth, low energy, or whatever. So it's something which is quite easy to do. And once again, it's a way to hack, in this case, the brain of someone, just by using all the inputs that connect the person to the world. So you don't need a physical access to some sort of plug to the person. Of course, most of these attacks are based on a standard and a basic buffer overflow approach. And many of the attacks that has been demonstrated, of course, they are working, but they also are based on the fact that the sources are widely available. Of course, you need to know if you want to do that quickly, which was the case. If you know the code which is behind, of course, it's easier to do. something that has been said before is that now you have so many systems to collect a lot of data and to process the data. But once you have access to a number of connected objects, of course, it's very powerful because you can have access to information about people, about companies. You can do, say, predictive analysis, deep learning on the data, and so on. So it's really an issue to be able to collect this data so easily. I became interested recently in what is called transhumanism, which, as far as I understand, consists in augmenting, adding new features to the human. What I was describing with this compass at the beginning of my talk basically goes in that direction. And of course, when we are connected in some way, it becomes difficult to avoid these hacking techniques that I've just described. For those who do not read French, this guy has been augmented with a D2R2 features, and the doctor is saying the good news is that you are as intelligent as R2D2. The bad news is that you have the same voice. We can even go further, still using the same techniques. You know about the SETI project, search for extraterrestrial intelligence. The idea being to listen to radio signals coming from outer space and try to identify some intelligent pattern. Of course, we can imagine ET hacking Earth by pushing information to the SETI project. Why not? So the question is, how can we avoid that? Is it possible to avoid this kind of attacks? I have more questions on that than solution, as you can guess. One solution is to avoid any interaction with the outside, which is basically not feasible. The other solution is to define and check the input definition domain. I will show you that this is not also possible for many reasons. Why is it not possible? We have the physical world with all the input that can be generated by the physical world. We have the filtered input, which is accepted by an object, by a device, which is smaller in most cases than the real physical world. And you have the part of the signals which is expected by your application. And as you can see, there is this red area, which is possibly generated by the real world, which is not filtered, but which is kept by your filter when you collect the signal from the outside, but that you did not expect in your application. And this is the area that you can use to generate signals, to push it to a device, and to try to hack the device using this information. And this is what is done with all the examples I have shown before. One possible solution that it's not a solution, it's a direction that might be interesting to explore, is to use a trusted device to manage the input. The idea would be to collect signals coming from the outside inside a trusted device, do some sort of additional filtering, and then push it back to the processing system. I don't know how to do that. I don't know if it's a proper solution. I don't even know if it's feasible, but it's a direction that we are beginning to explore. So I welcome any idea, any solution, any question. Thank you. Any question? Yes?
Would it be, because now in the cybersecurity world we have this idea of sandboxing and detonating malware and stuff like that. Would it be that intermediary system that actually collects all the signaling after the filtering and actually, without impacting the real world, actually simulates what that input would be generating in the real world? And then, depending on that output, another layer of filtering will be applied, and only the signal that is not in that red area will be pushed to the real endpoint machine.
Probably we have, so this is quite close to that configuration. So you are running, instead of just filtering, you are running all the process in that and see what happens. The thing is that you probably get back to the same picture, which is this area, not in the input, but in the output that you will not be able to evaluate. So you will generate things in the real world, but you will compare it to something which is expected, but there is always a difference between what will be done and what you expect to compare. So we get back to the same picture, I think. Yeah, there is a loop.
And looping.
Yeah. Yes?
Yeah, people talked about some new botnet now here. I saw the last couple of days that it's going to outdo Mirai and blah, 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 based on, you know, sort of Internet of things. I don't know how true that is or not, but is there a way to think about like making these devices making them unable to connect at scale, to sort of have them not operate as a group? Could you come up with some way to sort of defend them? You know, because it does seem like one of the issues here is that when you put them all together, they gain power.
Yeah. There are 2 points in your question. If we consider the network aspects, I think we can use standard procedures. There is still work to do, but we can use standard procedures. One, again, the thing which is new is when they use different communication systems. For instance, there is a nice video on the web where they have put a Google Home and the Alexa from Amazon. They talk together and it generates a loop. And the system keeps on looping, and doesn't stop. So there are 2 things. On the network side, I think we can work with the usual tools, even if we still have some work to do. But once again, there is something which has not been addressed, I think, regarding the different kinds of input that we are not accustomed with in the standard network world. It's not really an answer, it's just ideas.
Yeah.
Any other question? Thank you.